One of the key requirements as a software engineer is to understand the underlying components of an operating system. It not only helps you to become a great engineer, but it also gives you a holistic view of how different components in the system interact. My name is Derek Rono, a senior software developer at Andela, and today we are going to be dissecting some of the concepts that cloud computing has embraced. Initially, business invested a lot of money in acquiring IT infrastructure. This infrastructure not only came with issues of cost, but it also brought businesses issues of scalability and availability. With cloud computing, you abstract all this physical infrastructure into a software. As a software engineer, it's imperative for you to understand the underlying concepts because, one, it helps you to understand what problems are occurring and why communication is not happening. It also helps you to understand how to route different communications to different applications. The Unix operating system is well known for powering networking devices. And since networking makes up the bigger component of cloud computing, we need to understand how Unix controls the flow of traffic. I'm going to talk about 3 scenarios which explains the different traffic flows. The first scenario is where we have 3 points: point A, point B, and point C. So consider point A to be your home laptop and point B to be a company machine, which filters traffic going to another location of your company. The second scenario is 2 instances, your application server and a different company machine. So you're initiating traffic or querying a different server, so the traffic originates from machine A to machine B. The third scenario is where the traffic exists within a single ecosystem. So you have different applications running within the same machine, but on different ports. This can be used in instances of microservices. And since we now have a clear understanding of these different scenarios, then I would want to explain more about how each of these can be achieved, or what the Linux kernel provides for us to achieve these different scenarios. While your computer is acting as a router, the Linux kernel provides 3 chains: the input chain, the output chain, and the forward chain. The input chain is responsible for incoming traffic. The forward chain is responsible for traffic that is being forwarded through the machine. And the output chain is for traffic that is leaving the system. When you want to do manipulation, you can either use pre-routing or post-routing and different matches. So for instance, even if the packet IP matches a certain role, then depending on the stage, you can use pre-routing to modify the packet before it goes to the next step. You can use post-routing to modify the packet immediately before it gets out of the system. So to make us understand more about the post-routing and post-routing is responsible for handling or changing the packet destination immediately before it moves out of the system. Pre-routing is manipulating the packet immediately it comes into the system. And there are several other components that are involved and several rules that can be applied. And one of the tools that provide this capability is the IP tables, which is a software that allows system administrators to be able to create, delete, or manipulate these rules. Linux has some other very important tools that help us achieve what we have achieved with IP tables and also manipulation of packets. For instance, you can use the IP tool to redirect traffic to different hosts or through different gateways. TC helps you to also do traffic shaping. For instance, if you have a link for 300 Mbps and a link for 10 Mbps, you would direct traffic for video goes through the 300 Mbps link and direct any other traffic through the link which is at 10 Mbps. So these are very important tools which also come in handy, especially when we are defining how different components of our cloud systems interact. I know many of you might be wondering, how else do we get to understand how this traffic flows, or if it flows at all? There are different tools that you can use to analyze traffic in the Linux kernel. One of the tools is TCP dump. TCP dump provides you the capability to isolate traffic, filter based on different kind of rules, and be able to get insights on what's happening with your traffic. We also have Wireshark. Wireshark is a tool with a graphical user interface that allows you to be able to perform the same operations, but now with a physical interface and more power. Also, we do have Ping. Ping is a basic tool which I believe everyone has interacted with. It basically allows you to ask the other server or the other side that you are configuring whether they're receiving your message. In this video, we've talked about one of the components that make up cloud computing. This is software-defined networking. And there are three components that you need to keep in mind for you to be able to become a good software network architect. One is understanding the three different traffic flows. Two, understanding the tools, IP tables, IP and TC, which can help you perform different operations. And three is understanding the type of tools you need to use to analyze how what you've done is actually coming along. You can use Wireshark or Ping or TCP dump to be able to achieve this. If you want to learn more, I've dropped the links on the description, and also you can follow me on my Twitter handle. I'll be happy to answer your questions. Thank you for watching, and please remember to subscribe.